So this is what we did last time. We had, well, first part we converted rectangular coordinates to polar coordinates. But then I took two rectangular equations and I converted them to polar equations. The difference is with a rectangular equation, you have x and y. Polar equation would have r and theta. The first one doesn't have. Well, when we went from here to there, we did x is equal to r cosine theta, y equals r sine theta, squared, added, ended up getting 25. R became 5. We had to do some work here. We started there. And I said that would correspond to the equation of the limits. Standard notation, you divide by 4, keep that side as 1. So I just divided by 4 on both sides. That is the equation of the ellipse in its general form. So, yes. Okay. Now I want to graph this, even though the graphing section don't have to do it as homework, because you have your calculator. But anytime you have to put something in for the coordinates, you've got to change the mode in your calculator. So to change the mode from rectangular system to polar, how do we change from degrees mode to radians or radians to degrees? What did we do?
Using the equation or the calculator?
No, the calculator. Press button. You go from radian to degree. Yes. The next line, you've got function. PAR stands for parametric. DOL stands for polar. SU stands for sequential. Or sequence. Unless you're going to get into calculus, you wouldn't need parametric sequential. That is, if your next professor lets you use the calculator. So make sure you switch it to polar. And second mode. Now press Y equals. The letters would have changed from our traditional Y1 equals Y2 equals to R1 equals R2 equals and so forth. I guess that's good. So on the first problem, x squared plus y squared equals 25. We can learn that r ended up being just 5. So I'm going to type r equals 5. Good. And now, right. What does that look like? A circle. If you don't see things properly, you always go to zoom. I believe it's 0, which would be zoom fit. It will fit the screen to the curve that you want to look at. So in this case, I got a circle. The next equation, well, we convert it from rectangular to polar. We did our usual work, plugged in x is equal to r cosine theta, y equals 4 sine theta. And we got that equation at the very end. This time, when I plug in, it's not going to be y equals, rather r equals 30 divided by square root. Parentheses are important. 9 plus 16 sine square. Oops, that wouldn't work. So you have to put parentheses and then square. So open parentheses, sine. When you go and try to press X, it will automatically convert it to theta because it is in full rule. Naturally, you might ask, well, what about the T and the N? So let's say if you are good with logical deduction, rectangular mode, we simply have X when we press or when we wanted X. Now I switch the mode to polar. When I press X, automatically converts to theta. So what about the uppercase T and N? Just use logical deduction. Any thoughts? I'll give you a hint. Goes back to mode. When I explain modes on this calculator, okay, then. T will automatically pop up if your calculator is in front of you. Anything you type here will be converted to M if you are in sequential or sequence. So I have sine theta. We've got to square it. What is missing? Parentheses. That would close the entire term that is inside the square root. Adults, the end. So, do. What do you see? Not a perfect circle, but sort of this stretch, right? It is an oval. Sure, you can make it. Let's see. I am going to change the 9 to 2. Stroke for some reason. Well, calculators can't do it all. Let me change this to 5, and hopefully that works. 5 divided by 9 plus 16 sine squared theta, so sine theta square close parentheses from zoom 0. Funny looking ellipse. Well, that's the best the calculator can do. Good. So. A computer software will do that job. But then I'm sort of guessing, the equation of the elements. Maybe something's going on here, but you do see that I've converted x squared plus y squared equals 25 to Euler system. Plotted that using the polynomial, got a nice little circle, converted this equation, Euler equation, plotted it using polynomial, got the corresponding curve. And I mentioned last time, well, why do we have to do this? Anything that is a curve or curve-like, it is not possible, or it is possible, to analyze them or analyze it in the rectangular system, but it won't satisfy the properties of the function. Sometimes you have to make it a function. You have to make sure that's one-to-one. Lots of things that you've got to do in order to analyze a curve. A good one, Lemniscate, infinity. So, in order to graph that curve and analyze it, too much work, we would rather put it in Euler system. Does that make sense? And of course, they have a lot of practical applications.